Hey guys, today we're going to start chapter 10, and as requested, I've made a couple of videos for you. Today we're going to be looking at the results from our spelling test a couple of weeks ago, and I would like you to start with the most frequently misspelled word. So there is an online version of the Oxford English Dictionary that is used to track like with keyword tools and things like that, how often people are searching for the wrong spelling of a word. The most commonly misspelled word, according to them, is accommodation. So pause the video, make your best guess at how to spell accommodation, and then restart it when you're ready. All right, here's the correct spelling. Did you spell accommodation correctly? If not, that's okay. It is one of the most commonly misspelled words. When we did our spelling test in class, these were the 5 words that you spelled. So remember, the first word we spelled was lollipop, liaison, beautiful, unfortunately, and unforeseen. And the scores for our class ranged from 1 word spelled correctly to 4 words spelled correctly. I don't think anybody had all 5 words spelled correctly. So what we are interested in looking at today is there a difference in the proportion of words spelled correctly for male students and female students? So here are the results for our class. We had 55 attempted words by the male students in our class, and we had 50 attempted words by the female students in our class. Male students spelled 29 words correctly out of 55. Female students spelled 27 correctly out of 50. And since we have a different number of words attempted, we're going to calculate a proportion for each of those so we can see how those compare. 29 out of 55 is 5.27 repeating. So we'll round that to 3 places and call that 0.527. 27 out of 50 is 0.54. So we're going to then look at the difference in the proportions, and we're subtracting male minus female, so we get a negative difference of negative 0.013. So there is a little bit of a difference, but what we want to know is this difference significant, or do male and female students essentially spell with the same level of accuracy? So it says, what is the true difference in spelling accuracy between male and female students? And we're going to answer this question by calculating a 95% confidence interval for this true proportion. And we're looking for the difference, remember, in correctly spelled words. So on the next page of your notes, there's a box, and inside the box is another box. And in that little box is the formula for a 1 sample Z interval for P. And this is a formula that we learned back in chapter 8. So this is a formula you've seen before. And remember, the general format for a confidence interval formula is we take the statistic, which when we're working with 1 sample is P hat. And then we do plus or minus a critical value. And then remember, this part right here is what we call the standard error of our statistic. And we use p hat to calculate that because we don't know the parameter. In this case, we are working with 2 proportions because we have 2 different populations. And so we have a formula for working with two population proportions. So notice this is called, what it says at the box at the top here, a 2 sample Z interval for the difference between 2 population proportions, P1 minus P2. And this is what your formula looks like. So instead of P hat, we're going to use P hat 1 minus P hat 2. So that replaces our statistic P hat because we have 2 proportions this time. Then we do plus or minus just like before. We're still going to use a Z critical value because we're working with proportions. But now we have to change the formula for the standard error of our statistic. And this is going to look overwhelming, but it's really not that bad. So there's the formula. And as you're copying that down, I want you to notice a couple things. First of all, there are 2 parts to it. And part number 1 looks just like this part over here, right? This standard error part, except we're using P hat 1. And notice in the denominator, we're using N1. And then we repeat that same calculation for proportion number 2. So we're using P hat 2 and N2. And then because we are combining the populations together, or looking for the difference in them, we add those together, and then we take the square root at the end. So this formula, even though, like I said, it looks a little bit scary, is just a variation on the one sample formula that we used before. All right, so let's go through the steps of calculating the confidence interval. So when we state our parameter, and again, we're doing a confidence interval, so we use panic. We're going to do the 5 steps. We want to define what our parameter is. And the parameter we want to estimate this time is the difference in the proportions, so P1 minus P2. And we need to specify which proportion is which, because the order you're subtracting in, of course, is important. So in this case, I'm going to define P1 as the proportion of words spelled correctly by the male students in our class. P2 is the proportion of words spelled correctly by the female students. It does not really matter which order you subtract them in. I just chose that order because that's the way they were in the table that we recorded the data on page 1. Now for the assumptions, we still have to check the random, the normal, and the independent condition. We will assume that students in our class have been randomly selected. For the normal condition, remember, we're working with 2 population proportions. So normally we do the large counts condition, which is that n times p is greater than or equal to 10. But because we have 2 different populations, we have to do those checks for both of them. So remember from the first page, we're just going to recopy these values. P1 or P hat 1 was 0.527. N1 was 55. P hat 2 was 0.54. N2 is 50. And so these are the numbers we're going to use when we check the large counts condition. So there are actually 4 checks we have to do this time instead of 2. So there's the first one, which is N1 times P hat 1. There's N1 times 1 minus P hat 1. And then N2 times P hat 2. N2 times 1 minus P hat 2. And all of those are greater than or equal to 10. So what that tells us is that our sampling distributions are approximately normal. We would actually have 2 different sampling distributions. Now, we are not sampling without replacement. This is more of an experiment. So we're going to just say for the independent condition this time, we don't have to check the 10% condition, but we'll say that the individual responses in the 2 samples should be independent. I specifically asked you when we were taking the spelling test not to copy off your neighbor. So hopefully you followed those directions and your score is not dependent on the student next to you. All right, so we've got our first 2 steps out of the way, parameter and assumptions. Now for the name of the interval, we are going to call this a 2-sample Z interval for P1 minus P2. It's 2-sample because we have 2 separate data sets, male and female students, and we're doing an interval, not a test. And for proportions, we always use Z. Now for the calculation part, that's the I step. We're going to calculate our interval. I'm again going to fill these values in because this is at the top of page 3 in your notes, and that way you don't have to flip back and forth again. And we're going to plug the numbers into the formula that we wrote down at the top of page 2. So we remember for our statistic, we do P hat 1 minus P hat 2. And they tell us in the directions that we are doing a 95% confidence interval. So I looked up my critical value from the table, and I know that Z star is going to be 1.96. So again, there's P hat 1 minus P hat 2. So that's the statistic, plus or minus critical value. And then we're going to plug the rest of those numbers into the formula for the standard error of our statistic. So that's what that would look like. So remember the first half of that, the 0.527, the 0.473, and the 55 come from population 1. The second half of that, the 0.54, the 0.46, and the 50 come from population 2. And then we need to just do some calculator work. I would recommend that when you type this in your calculator, that you type all of this in parentheses. So 0.57 or 527 times 0.473 divided by 55, put all of that in parentheses, then add all of this in parentheses and hit enter. And then take the square root and then multiply that result by 1.96. And that will give you the margin of error. So 0.527 minus 0.54 is that negative 0.013. That's our statistic. And then the margin of error works out to be 0.191. So then we get to our conclusion, and we say for our conclusion, we can be 95% confident that the true difference in proportions of words spelled correctly Male minus female is between negative 0.204 and 1.78. And that was the negative 0.013 minus the margin of error and plus the margin of error. So notice that some of that interval goes down into the negative range, some of it is positive, and more importantly, the interval contains the value 0, which essentially tells us that there really is no significant difference in the way that male and female students spell in terms of accuracy. All right, video number 2 is going to walk you through example 2, which is going to be a 2-sample test for a population proportion. So please watch video number 2 and email me if you have any questions.